So as we do this, guys, I'm going to put the formula that is on your formula sheet on the side here. This is what's on your formula sheet. All right. Hey, what's the point estimate, you guys?
964.
And it is not 964.
It's 95% of 964.
It's not, no, it's 964 out of 1,100. Because remember, what we're trying to estimate is the proportion, the percent of people who are pro Buckeye. You guys, what is 964 out of 1,100? 0.87?
Yeah, 0.876.
0.876, perfect. Okay. All right. So, guys, what would my Z equal if I wanted to be 80% confident?
Plus or minus 1.282.
Let's see. This would be 0.8. What would that make the tail?
0.1. Oh, yeah.
And you got 1.28?
What's the point in writing it in the tail? Like, what do we use that for?
We're going to need to later on.
Okay.
Later, like next week,
Okay.
we're going to have to, you're going to have to do something slightly different, and you won't, wait. Yeah, next week. I had to look at what if we got to it this week. Next week, you're going to have to do it on without,
Okay.
yeah, in a different way, but same reasoning. So I want to practice the reasoning.
This has 7 and 8.
It's a 7 and 8. Okay, are you guys with me? That if I think through that formula, then I'm going to have p hat plus or minus 1.28. And then let's see. P hat was 0.876. What would that make Q hat? 0.124. You're just doing 1 minus that 0.876, yeah? All over 1,100. And then we're taking the score. Now,
So wait, does 95% have anything to do with this?
oh, you guys, I got a typo here. That should be 80%. We never did a 95%. But it doesn't affect. Everybody good?
Yeah.
Okay. And from this, just plug it into the calculator.
And the answer will be just plus or minus.
So you're going to do 0.876 minus the whole that whole thing, and 0.876 plus the whole thing. I'm okay with some people doing one side and some people doing the other.
Strawberry lemonade.
What did we get, Neil?
0.888 or 0.889 for the plus.
Okay.
No?
It's different.
No, that's good.
No. For the plus, I got 0.863. For the minus, I got 0.889. I did plus. 0.876.
You used the negative Z. So you said 0.863 was the lower? Is everybody good with this? Okay. You guys. It turns out there is a calculator shortcut to get here. Would you guys like to see it?
Yes.
Yep.
Okay. I would like you to, okay, in your calculators, hit stat. And I would like you to go over to where it says tests. We are doing, this isn't a test, this is a interval. Okay? As you look at this, you might see a z-interval here, but what I need you to see is that there's also a z-interval here. You guys with me? And what is our interval trying to estimate? A proportion. So I need you to pick the one proportion z-interval. Okay? So that is A. All right. Then it's going to ask you three things. X and N.
Wait.
Does yours not ask you that? Nat, does yours not ask you for this?
It's asking Z interval, T interval.
Yeah, you got to pick one prop Z interval. Now, does it ask you for this stuff?
Yeah.
Okay. You guys, the X and the N are the values that make your P hat. So X is essentially standing for your number of successes, which in this case was 964. And then for the N, we're going to put in. And for the confidence level, 0.8.
Oh.
Because it's an 80% confident, yes? Is everybody with me?
So,
And then I go down to calculate.
why do we use exactly the same?
You don't, is what I'm trying to point out. There are things, there's ways I could ask about it where you need to understand where the margin of error comes from.
What about the negative? I mean, yeah,
What about what?
the negative for this.
Writing down.
Because we only got the positive answer.
No, the 0.863 was the negative answer.
I got my positive answer.
Only
What did I get?
doesn't
No,
use
I got
this.
0.889 for
None.
That's all you got.
one prop C
Why didn't I get an answer at all?
Wait, did you do one prop Z interval or one prop Z test?
Nah.
One prop,
Where's
the,
this at? Tell me out.
that's exactly what
Where we go?
Maybe I do
prop
wrong.
C is.
Nah.
Let me do
That'll help me.
Oh,
Kind of deaf lost.
they literally gave me another.
No. Get back over here.
That got me no answer, so.
Oh, your confidence level is the 80. Would be 80% confidence.
I did mine right actually, so.
Chocolate?
Okay.
we get the same answer.
Cool, awesome.
Okay.
Every good?
Yeah.
Thank you.
Yeah. Press enter.
We were dogging on it.
No, press enter then you're only possible.
You guys, if I wanted to use this interval to get my margin of error, what would I do?
Just take off the 0.876
So you have two options to find the margin of error. I could either do 0.889 minus 0.876, or I could do 0.876 minus 0.863. Either of those kind of undoes adding and subtracting the margin of error.
Wait, where'd you get those numbers?
The intervals, the endpoints of the interval, and then the p hat.
Oh, it's just like, so you're subtracting something from the P hat or the P hat from the lower.
Oh,
Yeah, it's either the upper boundary minus p hat or p hat minus the lower boundary.
okay.
All right, and let's see. You guys, I'm getting 0.013. Does that feel right?
Yeah.
So that was my margin of error. Okay, guys, another thing of noting, the width of the interval is equal to 2 times that margin of error. All right, we will pick up from here tomorrow. Recording. All right, so you guys, here's what we know. 3 out of 30 students said that they talk to themselves while studying. Do any of you guys talk to yourself while studying? I bet you do.
Yeah, I
He
did.
definitely does. I did.
Yeah, like you like teach a class, then it like makes you seem like you know what you're doing.
I talk to myself while running. I'll be like running, like, you got this. Come on. And I say it out loud. and it never fails like on one of the really long runs. That
Does
like
it
I'm
take your
passing
breath away?
somebody. No,
I don't think I can.
I don't run that fast. But I'll be passing somebody at the bike path, on the bike path, and sometimes my self-talk isn't as good as it should be. Like, come on, you're better than this. You can do better. And sometimes I get really nervous that people think I'm the weirdo, or even worse, that they think I'm talking to them. Like, come on, you can do better than that. So funny. Do any of you guys ever have like conversations inside your like you
like,
practice a
yeah,
conversation in advance?
Yes.
But sometimes I say it underneath my breath, and so I'll be like at home doing the dishes, practicing a conversation, and Yaro's like, "What? Who are you talking to?" And I'm like, "I don't know what you're talking about. I'm not talking. It's all in my head." And he's like, "It's not in your head."
Or like after you have a conversation, you like reenact the whole thing.
No, I was walking to school yesterday practicing what I was gonna say to my interview, and I was literally like right from school. So people must be seeing me right now. Just talking right.
No, but they might think about you how we feel about the dancing lady,
Sure.
who we haven't seen in a while.
But every time you see
But, like-
that lady, everyone says that's gonna be me, without a doubt.
But like,
Dang.
not
She's
only
so
is it.
confident though. That's
Not only is it going to be me, I want it to be me, right? Like, that's who I want to be when I grow up.
Yeah, she's awesome.
Okay.
No, she's totally fine. She's just very confident.
I saw her driving. Like,
Yeah, and she drives a
dancing.
white Subaru.
She was dancing while she was driving. I was like, all right, lady, you gotta cut it. We're driving on the road. And she's like, put both hands up.
Okay, you guys. So if we take a sample and find it's 3 out of 30 people who are talking to themselves, what would my point estimate be? And what symbol would we use for it? P hat. I am, like the last test, I wasn't super picky about if you wrote out the like probability statements and stuff. I am going to be picky about symbols here because the type of symbol we use tells us what to do. And right now, we're only estimating P's, so we only have one symbol. So I am going to be very picky about how you write those things, okay? And 3 out of 30, I bet we don't even need a calculator to figure that out. Yeah, it's 10%, yeah, 0.10. Okay. You guys, can you tell me what Z do I need for 80% confidence? Let's see, that would be middle 80%, right? What would that make my tails? 0.1. So when you guys do the inverse norm of 0.1, did you get 1.28? It's not. It's 1. You can't see that? So my Z is 1.28. And my margin of error would be that 1.28 times 0.3. And by 0.3, I don't mean 0.3. Don't write down the 0.3. 0.1 times 0.09 or 0.9. You guys, this is like, don't listen to Meister today.
What?
Jeez.
And you should take the inverse norm of 0.1.
Why?
Yeah.
Because the left-hand area is 0.1. If you did the inverse norm of 0.8 and you chose center, you're fine. I'm always going to model this one.
All right.
Because what you guys have to do next week, you have to understand this reasoning process. Okay? Because next week, we're going to use a different function that is very similar to the inverse norm. And that function in your calculator doesn't say left, center, and right. So I want you to get used to using the half of 1 minus this. Okay? Everybody doing okay? All right. Hey, guys, what are you getting for that margin of error? 0.07. Lovely.
Maybe I just can't read what you have on top.
I have 0.1, 0.9, 30. Did you multiply by the 1.28?
I did 128. Okay.
That would make a pretty big difference, yeah.
Are we finishing 7-2?
We are finishing 7.2 today.
And where do we get the 0.9 again? Is it just the
Q hat?
So you had to make it equal 100 on the top? Or 1?
1. Yeah, yep.
Is that not just C, what we just did?
C is what we just did. If you did it by hand. Okay, you guys.
So why can't
Oh,
you
right,
just
because
do?
you can do it in your calculator.
Why can't you just do 1.1 over 3?
Because that's not the formula.
It's the,
Even though you're trying to get it to equal 1.
I don't think we're on the same page, Nat.
This mad.
The two probabilities on the top, when you're multiplying those two probabilities.
Mhm.
However, the two probabilities should add to 1.
Yeah. So my question is, why don't we just?
Because multiplying and adding would be different. We could do different ways.
Yeah, so 0.1 plus 0.9 is 1. 0.1 times 0.9 is 0.09. I guess I'm not understanding your
Yeah,
question.
There's multiple ways to get one by like adding, but that's gonna change it when you multiply. You can't just use one. Like if you did like 0.2 and 0.8, then you get a completely different answer.
Yeah, you get
Both would
0.16.
Add up to 1.
Okay.
Okay, the formula, and again, this one's on your formula sheet, you won't need to memorize it, is that part of the formula is p hat times q hat over n. And that formula is there, and remember that q hat is 1 minus p hat. And then you're just filling into a formula. You can think of it that way. Okay? All right, so what is my interval?
Oh, one's
point of 7.
Well, the 0.07 is my error, so my interval is going to be plus or minus that 0.07. And what was my point estimate? 0.1 from the previous part, right? The 1.28 became the 0.07, right, when we multiplied those two things? Okay. And then, so you guys, as I look at that, I'm looking at 0.03 to 0.17.
Okay.
Are we okay?
Yes.
All right, then I also showed you if you wanted to check, and honestly, you are allowed to just use this to get to your interval. I don't care. I'm sorry?
It'd be negative 0.03.
So it's 0.10 minus
0.1 minus 10% minus 7% is positive.
Oh, I did 0.0, so yeah. That's 0.07.
Okay, you guys. We hit, just a reminder of where to find this. Stat, arrow over to tests. You want to choose option A for this one, a z-interval for a proportion.
Okay.
When it asks you for x and n, it's asking you for my number of successes, which was 3, my sample size, which was 30. Oh, we should probably, clear that other stuff out. Okay? You put in whatever the confidence level is. And look, 0.03 to 0.17. It's the exact same interval. Is this okay?
I suppose.
Now, something I didn't show you and I should have showed you yesterday was how to interpret this interval. When we interpret an interval, remember Mr. Johnson's age? How did we know if our interval was correct?
By other facts, like his.
Well, that helped us shrink our margin of error. But for instance, Ms. Meister's estimate was 52. And when we used plus or minus 2 years, I said he's somewhere between 50 and 54. You guys with me? Was I right?
Yes,
Yes? Why?
because you knew.
Why is 50 to 54 correct?
Because he's 54.
Because his age is inside that interval. Okay? Is everybody with me? All right.
Yes.
Now, in general, this comes from a sample. And what do we know about samples?
They're not perfect.
Samples are not perfect.
Okay? All right. So, and in fact, we're only 80% confident. Okay? So the way we're going to interpret this is with 80% confidence, we can say the population proportion of students who talk to themselves while studying is between 0.03 and 0.17. Are we feeling okay?
Yep.
All right. Now, what would happen to my margin of error if we became 90% confident? So we're more confident. What would happen? That's a lie. It would increase. You guys, let's go back. Hold on. Because this is a huge idea. So I want to it's important that we kind of work this through. Numerically. All right. Now, how do we calculate that margin of error? 1, we've already done it. But let's pretend for a second that we didn't calculate this by hand and instead went straight to the calculator. Is this okay? All right. If we went straight to the calculator, we would end up with that 0.03 to 0.17. And there's 2 ways we can think about that margin of error, okay? Since we know the middle was 0.10, so in the middle of this is 0.1. My point estimate, right? Because if I plus and minus the same distance on each side, it's going to be the smack dab middle. Okay? So we could do 0.17 minus 0.1. We could do 0.1 minus 0.03. Is this okay?
Yes.
We could do one more thing that we didn't really talk about. The width of the entire interval would be how many margins of error? It's 2 margins of error, yes? A margin on the right, margin on the left.
Yes.
Okay? So this, you could get it this way, you could get it this way, you could get it this way. You could get it by doing how wide is my interval divided by 2.
Yeah.
All right. Now, okay. All right. This one also on your formula sheet. Okay. This formula is if you take that margin of error part backwards and solve for n, this is what you end up with. Okay. So in reality, it's like, let's say I'm going to run a statistical study, right? Like I'm the statistician that someone hires. In reality, that person's going to say to me, hey, I need this to be pretty confident. So I want it to be 95% confident, but I also want that margin of error to be relatively small. Okay? And if that's the case, I need that margin of error to be small. The only other way I can change the width of my margin besides my confidence is my sample size. Because the p hat and the q hat, we don't have any control over that. That's just the result of our sample. Is everybody with me so far? So, typically what happens is they say, well, how big a sample do I need for something to take place? Okay? All right. So, so let's say I want to be 95% confident and within 3%. Okay. If that is the case, I need my error to be 0.03. And I need, what would my z need to be for 95% confidence? Really close to 2.
Yes.
Really close to 2, but not quite. Well, what we do the same thing, right? So here's 95%. What would that make the tail? 0.025. And I'm pretty certain you get 1.96 because I know things. I know lots of things. I know the amount of z-scores I know are pathetic. I think I know them inside my head for 99, 98, 95, 90, 80.
Why isn't it exactly 2 again?
Because that empirical rule is an approximation.
Okay.
Z equals 1.96 is something that stats people jump at. They know, like, that's a very common one that they know because of this process. Okay. What else do we have? We're starting with a base estimate for p hat. Are you with me? That's what this 45% is. So we're going to use p equals 0.45 in our formula. Is everybody okay? All right. So if that's the case, my sample size is going to be, that I need is 1.96 squared times 0.45. You guys, if we use that, what's Q? 0.55 over E squared, which what was the margin of error we're hoping for? 0.03 squared. And like I said, you guys, this formula is on the formula sheet. I don't want you to stress out about remembering the formula.
Because we're determining sample size here.
Yeah,
So
so
it has to be a whole number.
it has, but there's rules about it. So tell me the decimal you get for now.
0.44.
1056.44? Okay. You guys, you are going to be tempted to say 1056 with sample size. Essentially, you could think of this formula, and it's not written on your formula sheet this way, but you can think of it as my sample size needs to be at least this number, right? A bigger sample size will have a smaller margin of error. You're still fine because you're going to be within that 3%. Okay? So for questions where you're trying to find the minimum sample size, whatever the decimal is, you round up. Okay, so don't think of it as rounding. You take it up by one. That your sample size needs to be bigger than or equal to this number.
Okay.
Is this okay?
So you're not rounding to the nearest whole, you're just adding one.
Mm-hmm.
One's close.
Well, but if it was like 1056.0, right, there was nothing, if there was no decimal, you would leave it as 1056. But certainly we're not asking 0.44 students something. So it like your sample size needs to be a whole number. And if it's more than a number, It's got to be the next highest whole number, because it's got to go up.
Okay.
All right. Determine the sample size necessary to construct a 97% confidence interval within 4%. So E is going to be 0.04, yes? And then Z is going to equal... No, because it's 97% confident this time. So we have to find it.
Yeah.
So what would the tail be? 0.015. This is not one of the ones I have memorized, though I could probably get pretty close to it. 1.78 is my guess. Am I close at all?
2 point.
Oh, I went the wrong direction. Interestingly, I went about the right amount in the wrong direction. Okay. Now, how is this one different than the previous question? I didn't give you a suggested p-hat, right? When that happens, you always use the same one. It's great. And that one you use is 0.5. So when no p-hat, you use p-hat equals 0.5. And it's just always that. Unless you're given something in the question that suggests it's earlier.
Wait, what's the 0.45, the p-hat?
It was our best estimate of what p-hat was going to be.
Okay,
That's the way to think about it anyway.
okay.
All right. So my sample size needs to be bigger than or equal to 2.17 squared times 0.5 times 0.5 over 0.04 squared.
735.76.
So 736.